Okay, solve this equation. X real. All right. So it's algebraically it's impossible to me, but my assumption is that you're going to try something that you learned in Math 119. I'm going to set it equal to 0. So 0 equals, and that would be 4x squared minus 3 to the x. Let's see, minus 6x, and then plus 5 to the x. I'm going to call this a function now. F of x equals 4x squared minus 3 to the x minus 6x plus 5 to the x. Let's start simple. Right? Just like you did in 119, you started with integers and you worked your way through them. Hope I'm going to find something pretty quick, by the way. Let's try the 0. You get 0 minus 1 minus 0 plus 1, and eureka, we found 1. So our first root that we found, or solution to the problem, is x equals 0. Let's look for another one, and that's going to be 4 minus 3 minus 6 plus 5. And let's see what happens there. 4 minus 3 is 1, 1 minus 6 is minus 5, and minus 5 plus 5 is, of course, 0. So I found another root, and that's x equals 1 now. Now, granted, you could search around for more, but you remember when you were in 119, you found some, and then you used those to see if there was others. All right. Now, in Math 119, you did long division, but right now I'm gonna use calculus. I'm gonna take a derivative, and so this is why you take a derivative. One thing you could do is determine when the function's increasing, decreasing, and get sort of like a general shape of it. But unfortunately, the first derivative is really difficult. Let's write this down now. It's going to be 8x minus the natural log of 3 times 3 to the x minus 6 plus the natural log of 5 times 5 to the x. And that's more nightmarish than the original problem, in my opinion. So I'm going to go for the second derivative. And the second derivative is going to give me about concavity, information about concavity. This is 8, let's see, minus the natural log of 3 squared times 3 to the x, derivative constant 0, now let's move on, plus the natural log of 5 squared 5 to the x. Now my suspicions about this derivative over here is that it's always positive. All right, if it's always positive, it means it's concave up. So let me, but I don't know that to be true at this point, but it looks positive. So we have a root here at 0 and a root at 1, and if that's true, it's concave up, and that means there's only 2 roots then. All right. So what I need to do is I need to show that that derivative is positive, and that could be difficult. All right. So we'll write this down, and we're going to split into parts. And the first part I'm going to split into is the part where x is greater than or equal to 0. All right. Now, what do I know in that case over there? I know, let's see, I know 5 to the x is greater than or equal to 3 to the x. Let me go through that with you. So if you look at this over here, let me use blue, and I'm going to draw a picture of an exponential over here. I'm going to say this is y equals 5 to the x. And let me draw the other exponential down, the 3 to the x. Well, below the 0, it's going to be above that curve. Then it's going to have the same y-intercept. It's above the curve there, and then it goes below the curve over here. So what do I know? I know that when x is less than 0, that 3 to the x is greater than 5 to the x. All right? So I think this is going to be the easy one to do first. All right? So let's do that first, and we'll walk through it. All right? So we're going to take that case first. This is the easy one. This is easy. All right, what do I know? I certainly know this is true. All right, I certainly know this is true. I certainly know the second derivative, I got that. Now, certainly, that's an equivalence. That's an equivalence. I noticed they changed something over here, though. You notice this over here. So the question is, I hope you realize that the natural log of 3 squared is less than the natural log of 5. So this thing here is greater than, right? All right, let's see if we can figure that out now. And what I'm going to do, I guess I'll factor it. All right, so let's take a look at that. And, I see the 8. I factor out the natural log of 3 squared from these two terms over here, and I would get 5 to the x minus 3 to the x. Well, what do I know about that? I know 5 to the x is greater than or equal to 3 to the x, that means 5 to the x minus 3 to the x is greater than or equal to 0. So this term over here is greater than or equal to 0, plus 8 is certainly greater than 0. So now I know that this derivative over here is positive when x is greater than or equal to 0. Now let's do the less than 0 part. That is more difficult to do. It's much more difficult, all right? It made me think, all right? Now what do I have over here? I still have this fact. I have this. And one thing I want to point out, I know this as well, all right? What I mean by that is, if I look at the curve of 3 to the x, let me draw a picture of that. I'll put it in red. Oops, I thought I said it was going to red, right? This is the y-intercept here. This would be 0, 1. And what do I know about that 3 to the x? And this is y equals 3 to the x, by the way. I know 3 to the x is definitely below 1, all right, when you're below the 0. All right, this is good. All right, so this is easy fact, easy fact, easy fact. The next thing I know about this is over here. I know that this thing is always positive. All right, that's pretty simple too. Now this one over, let's discuss this one over here, the natural log of 3. Well, the natural log of 3, I'm just going to say, what is it? I'll just call it some number a. And what is that going to be? Well, 3 would be equal to e to the a. All right? Now, I hope you realize that, I would, e's a number like 2 point something. And certainly I know if a is, could be 2, right? That's definitely going to be bigger than 3. Because even if you took e to be 2, 2 squared would be 4 is bigger than 3. So this seems to make sense. All right. What I do is square both sides. This makes sense. All right. Now we need all those facts to do this over here. All right, let's go through it. So I get 8 minus, and someone says, what happened to this term over here? Well, this is some positive number. All right. So clearly it's greater than. All right. Then what do? I start looking at this ln squared 3 over here, and then I write down, it's squared, it's the 4, right? And 4 is bigger than that, right? Let's take a look at that, see if I did that right. This is the part I'm always thinking, I have to think through it. ln 3 less than 2. Let's see, e squared. Let's take a look, I gotta be careful now. Yeah, I'm going to go. It's greater. Yeah, it's greater. Yeah. Let's keep going. And 3 to the x is less than 1, so this is greater than. And this is greater than 0. That means this is greater than 0, this is greater than 0, and this is greater than 0. So we just showed it. So what do we get over here? F double prime of x is greater than 0 for the x that are less than 0 now. So we showed it's greater than 0 for everything. What does it mean it's concave up? I do want to point out we do provide pictures. And so our graph concave up everywhere has 2 roots. We found the 2 roots by chance, but not really. They were simple. We're providing a graph over here on page 349, figure 97. It's right over here. Let me just briefly go through that with you. I have an x-intercept over here. This is 0, 0. I have an x-intercept over here, which is 1, 0. And I hope you realize I'm seeing something. No, that's not a parabola, by the way, but it sure does look like one. And what does it look like? It looks concave up, all right? Now, by the way, if I did the first derivative, I would find the absolute minimum over here. On this side, it's increasing, and on this side, it's decreasing. But again, I don't have the, I'm not going to try to solve that for that point over there. They don't ask for it anyway. Thank you.